Hello guys, welcome back to my channel. This is part 49 of ASP.NET Core tutorial. In this video, we will discuss what is repository pattern, benefits of the repository pattern, and an example that uses repository pattern to store and retrieve data from a SQL Server database using Entity Framework Core. What is repository pattern? Repository pattern is an abstraction of the data access layer. It hides the details of how exactly the data is saved or retrieved from the underlying data source. The details of how the data is stored and retrieved is in the respective repository. For example, you may have a repository that stores and retrieves data from an in-memory collection. You may have another repository that stores and retrieves the data from a database like SQL Server. You may have yet another repository that stores and retrieves data from an XML files. Let's understand this repository pattern with an example. We want to be able to perform all the CRUD operations, that is create, read, update, and delete. Instances of this employee class using the repository pattern in its simplest form. The repository pattern contains at least two participants, the repository interface and the repository class that implements the repository interface. At the moment, in our application, we are working with this employee type. So we named the repository interface iEmployee repository. If you are working with the product type, you would have named your repository iProduct repository. Similarly, if you are working with the customer type, then your repository would have been iCustomer repository. At the moment, our repository interface does not have all the CRUD operations. We only have methods that retrieve. We only have methods that retrieve all employees, employee by ID, and then a method to add an employee, and then a method to add an employee that is to create a new employee. We want methods to update and delete employees as well. First, let's include a method to update an employee. This method is going to return us the updated employee. So let's set the return type to employee. This is the return type. So let's set the return type to employee. Let's name the method update. And then we also want to pass the employee object that has the changes. So let's pass a parameter of type employee. So let's pass a parameter of type employee, and I am going to name the parameter employee changes. And then let also include a method to delete an employee. Again, this method is going to return us the deleted employee. The name of the method is delete, and to be able to delete an employee, we need the ID. And to be able to delete an employee, we need the ID of that employee. Let's pass it as parameter. We have passed it as parameter. Now the important point to keep in mind is the repository interface only specifies the operations that are supported by the repository. That is the method that are supported by this repository. For example, this repository can retrieve an employee by ID. This repository can be this. For example, this repository can retrieve an employee by ID, and to be able to do that, it need the ID of the employee that it wants to retrieve and return that employee. So we have set the return type of this get employee. So we have set the return type of this get employee method to employee. So the point that I am trying to make is the repository interface. The repository interface only contains what operations are supported by this repository. It does not contain the details of how those additional it does not contain the details of how those operations are performed. Those details are in the repository class that provide the implementation for this repository. For this repository interface, we already have one such class, and that is the mock employee repository class. This specific implementation stores and retrieves employee objects from an in-memory collection. Notice at the moment we have a red squiggly under employee repository. That is because we have added two methods to the interface, that is update and delete, and at the moment we have not provided implementations. So let's provide implementation for those two methods by clicking on this option. Implement interface. First, let's provide the implementation for the delete method. We want to delete the employee from this private field underscore underscore employee list. We want to delete the employee from the private field. Underscore employee list. To find the employee within the list, let's use first or default. To find the employee within the list, let's use first or default method. First or default method. To find the employee within the list, let's use first or default method. The ID of the employee within the collection must be equal to the incoming ID. Must be equal to the incoming ID. Let's store that employee in a variable. Let's store that employee in a variable of type employee. In a variable of type employee, we have stored that in a variable of type employee. If the employee is not equal to null, that means we have found the employee and we want to remove that employee from the collection. We use the remove method. We use the remove method for that, and we want to remove the employee that we have found. And then finally, let's return the employee that we have deleted. Return the employee. Let's return the employee that we have deleted. Why we get this squiggly, green squiggly? because the implementation for update method is going to be somewhat similar to this code. The implementation for the update method is going to be somewhat similar to this code. So let's make a copy of it, paste it within the update method, and then make changes that are required. To get the ID of the employee that we want to update, let's use this incoming employee objects. Once we have found the employee, we want to update the data that we have in this employee object, with the data that we have in this incoming employee changes. Employee changes object. So employee.name employee.name equals employees changes.name. Employee dot email equals employee changes dot email. Employee dot department, and then finally employee dot department equals employee changes dot department, and then return the updated employee. So what we have done so far? We included our repository pattern. We included our repository interface. Repository interface, I employ repository. And this interface is capable of performing all the CRUD operations against the employee type. We already have one implementation for this repository, and that implementation is in this mock employee repository class. That implementation in this employee repository class. This implementation stores and retrieves employee this implementation stores and retrieves employee objects from an in-memory collection. We want to provide another implementation, and we want this implementation to store and retrieve employee object from a SQL Server database using Entity Framework Core. So let's add another class file to the model folder. So let's add another class file to the model folder. I'm going to name it SQL Employee Repository. SQL Employee Repository. We want this class to provide the implementation for our repository interface. I employ repository. So let's make this class SQL Employee Repository. So let's make this class SQL Employee Repository implement our repository interface. I employ repository. Implement our repository interface. I employ repository. We want this implementation to store and retrieve objects from a SQL Server database using Entity Framework Core. To be able to connect to the SQL Server using Entity Framework Core, we need DB context class. We already implemented this appdb context class in our previous video in this series. Let's inject this appdb context class into our SQL employee repository class using the constructor. Using the constructor. So first let's include a constructor. And then inject the appdb context class. Let's name the parameter context. And let's press control period. Control period. In Visual Studio to let Visual Studio generate the private field. Next, we need to provide implementation for all the CRUD method. Let's start with this add method. We have the context. We have the context object. On the context object, we have the employee property. Let's use the add method to add this incoming employee. Let's use the add method to add this incoming employee object. To be able to save this employee object in the underlying SQL Server database employees table on the context object, we have to call save changes method. Let's finally return the added employee object. Let's finally return the added employee object. To delete an employee, we must first find and retrieve the employee. So let's use the find method. So let's use the find method on the employee property of the context object. Let's store the employee that we have retrieved in a variable of type employee. Let's store the employee that we have retrieved in a variable of type employee. If employee is not null, if employee is not null, if employee is not null, that means we have found the employee that we want to delete. So let's delete the employee from the employee property on the context object. For that, we use the remove method. Call save changes on the context object. Call save changes on the context object to save the changes in the database, and then finally return the deleted employee. And then finally return the deleted employee. Get on employee is pretty straightforward. We want to return all the employees, so let's return context.employee. context.employee. Next, get employee. This is also one line of code. We need to find employee by ID. We need to find employee by ID. So on the employee's property of context object, let's use find method and find employee by ID. And let's return that employee. And let's return that employee. The implementation of the update method is slightly different. We take the employee object that has the changes and attach it to the employee's property of the context object. Attach it to the employee's property of the context object. We use the attach method. For that, and whatever this attach method returns, let's store it in a variable. And whatever this attach method returns, let's store it in a variable of type. Let's name the variable employee. Notice from the IntelliSense, the attach method returns entity entry. Notice from the IntelliSense, the attach method returns entity entry of the employee. Entity of the employee. Now we have to tell entity framework the entity that we have attached is modified. The way we do that is by setting the state property on the employee entity of modify. on the employee entity to modify. Now we have to tell entity framework. The entity that we have attached is modified. The way we do that is by setting the state property on the employee entity to modify. Next, on the context object, call save changes method. Next, on the context object, call save changes methods. When the save changes method is called, that is when entity framework issues the required update SQL statement to update the data in the employees table in the underlying SQL Server database. Once the changes are saved, let's return the updated employee objects. Once the changes are saved, let's return the updated employee object. At this point, we have our repository interface, IEmployee-repository, and there are two implementation: in-memory implementation in mock employee repository class, and SQL implementation in SQL employee repository class. And then if we take a look at home controller, and then if we take a look at the home controller within our application, notice we are injecting our repository interface employee repository into the home controller using constructor. And then we are using this injected employee repository interface in all the controller action method. Notice we are using it in index action method right here. In the details action here. And even in the create action here. Now the important point to keep in mind here, is notice nowhere in this controller, we are specifying whether we want to use the in-memory repository, in-memory implementation, or the SQL Server implementation. Okay. Nowhere in this controller we are specifying whether we want to use the in-memory implementation or the SQL Server implementation. The only thing that we have specified is we are saying we want to use this interface. We are saying we want to use this interface employee repository. So the obvious question that comes to our mind, that comes to our mind at this point is, how does the controller within our application knows whether they have to use mock employee repository or SQL employee repository instance? Well, the answer to that is in the configuration service method of our program.cs file. So if we take a look at program.cs file, notice you have registered mock employee repository class. So with this one line of code, we are basically saying if someone like this home controller asks for an instance of employee repository, then provide them an instance of mock employee repository. In our case, we want to store and retrieve employee object from a SQL Server database. So instead of using mock employee repository, we want to use SQL employee repository. So with this one line of code change, our entire application right now switches from storing and retrieving employee objects from an in-memory collection to SQL Server database. So this is the power and flexibility the repository pattern combined with dependency injection provides us. Now with a SQL employee repository, we want to use add scoped method to register our service. Add scoped. If you are wondering why I am using add scoped method, well, that is because we want the instance of the SQL employee repository class to be alive and available throughout the entire scope of a given HTTP request. When a new HTTP request arrives at our application, we want another new instance of this class to be created, and we want that instance also to be alive and available throughout the entire scope of that HTTP request. That is the reason we are using add scope method to register our service. In addition to add scoped, we also have add transient and add singleton method. We discussed the difference between these three methods in details in part 44 of our ASP.NET Core tutorial. What are the benefits of repository pattern? Well, the code is cleaner, easier to reuse and maintain. It also enables us to create loosely coupled system. If we take a look at our application, it is very loosely coupled with the specific implementation of the repository. At the moment, our application is working with the employee object in the SQL Server database because we have registered our SQL employee repository here. Now, if we want to switch our application to work with employee objects within in-memory collection, then all we need to do is register our mock employee repository here instead of the SQL employee repository. With this technique in a unit testing project, it is very easy to replace a real database repository implementation with a fake in-memory implementation for testing purpose. With all these changes in place, let's run our application. Save this. Build the solution. So with all these changes in place, let's run our application and see what happens. Notice notice we have an error. Cannot open database employee DB34. And this error makes sense because we don't have this database created yet. We will discuss how to create this database in our next video. Why I am using employee DB34 because I have created many employee DB database. That is why I was confused. So I use this employee DB34. Okay. So we will discuss how to create this database in our next video using entity framework core migration. That's it in this video. Thank you for listening. Have a nice day.